The chat is working. If you have any questions, anything you want clarifying, anything like that, there is a Q&A section that you can use when you'll be talking to Dr. Evans. My name is Mr. Bentley. I teach at Pengleiss. Dr. Evans teaches at Pengleiss. And for the AS sessions, we've just picked 4 topics. We've picked coordinate geometry today, differentiation next week, integration the week after, and trigonometry to finish. If there's anything specifically you want us to cover that you might feel would benefit, you could put something in chat. We may or may not be able to cover it. We can't promise anything. We will listen to you. We will react to you. Those of you who know me will know that I'm very old-fashioned. I don't do all singing, all dancing. I use pen, paper, and a visualizer. At the end of the session, all the sheets I show you today will be emailed out to you. Now, you might want a pen and a piece of paper. You might want to jot things down, follow through my working, or not. It is entirely up to you. So, coordinate geometry. Now, my next thing is I'm going to spend lots of time looking this way, so I'm not ignoring you. My camera's on the computer, but my visualizer's down here, so I'm going to be looking this way. Now, where to start? I'm not teaching. I'm revising, reviewing, and giving you my thoughts. Now, this is not to replace anything your teacher's told you. This is to sit alongside it, to reinforce, to clarify. Okay, if you've got anything you want to ask, then ask. It's quite, and actually, coordinate geometry, we're sort of jumping into the middle. So I thought, where are we going to start? Graph of a straight line. What is the graph of a straight line? It's any connection between x and y that would simplify to that. Y equals mx plus c. In other words, y to the power of 1, x to the power of 1, plus a constant, okay? And we know that it will simplify to that form. M will give you the gradient and c will give you the intercept. And from that, in that form, you can always sketch the graph of the function, okay? Because you can draw your x and y axes, put the point in, label it, draw a line, and you have a sketch graph. And actually, all the graph work you did in year 11 was leading to be able to do that, so you don't have to draw accurate graphs. Now then, finding the equation of a straight line. Really, what you will always need 2 things to find the equation of a straight line. The gradient plus 1 point on it. Now, if we look here, if y equals mx plus c, if m is the gradient, and you've got 1 point on it, you've got an x, you've got a y, if you substitute the x, the y, and the m into that, you could get c, and hence the equation of the straight line. However, there is a shortcut that I use. Now, a little bit of notation here. Given the gradient is m, and our point we call x1, y1. X coordinate of point 1, y coordinate of point 1. And that little formula there gets you to the equation of the straight line. So here's a nice example. Find the equation of the straight line, gradient 1/4, passing through -4, -3. Have a look at that. If you've got a pen and a piece of paper, you might want to make a start. I'll give you 1 minute to get your head around it and make a start, and then I'll go through it my way. Okay. I always treat a maths question, A-level maths question, as a recipe. Here's my ingredients. I've got an M. Oh, good grief. I've got an M. Is 1/4. I've got x1 is -4. I've got y1 is -3, and they're my ingredients. Here's my recipe, the formula. Y minus y1 equals m brackets x minus x1. Top tip from Mr. Bentley examiner. Okay, I am an A-level examiner. You will always get a method mark for correctly using the right formula. If you don't write the formula down and you make a mistake, you lose that mark. If you write the formula down correctly and then put your numbers in to make a mistake, yes, you'll get the method mark, you lose what's called the accuracy mark. It's always worth writing the formula down. Y is part of my answer. So y minus y1 is -3 equals 1/4 x minus -4. Now, I'm putting all my working in, okay? The minuses make a plus, as we know. What I'm going to do now is get rid of the fraction. So 4y plus 12 equals x plus 4. I'm petrified of making a mistake. And then there are various ways you could write the answer down. To be honest, any 3-term equation is correct, unless you're specifically asked for a certain form. You might be asked for it in the form ax plus by plus c equals 0, or ax plus by equals c, or y equals mx plus c. So we could say 4y, I keep pressing that, 4y minus x equals -8. Or we could say 4y minus x plus 8 equals 0. Or we could say, I've got to be careful now in my head, y equals 1/4 x minus 2. And all three things are rearrangements of the same thing. Just check the question, what forms you want, and off we go. Nice, easy, bookwork, one formula. So, and you're going to use that an awful lot. You might use the y equals mx plus c method. That's the way I do it. And I know Dr. Evans perhaps doesn't. I don't think she does. Now, gradients. We know what the gradient is, the measure of the slope. You probably started finding gradients in year 11 by drawing right angle triangles on graphs and changing y over changing x. You know now, changing y, changing x, delta y over delta x, dy by dx, differentiation, gradient, all fits together. So there is a formula that does exactly the same. Y2 minus y1, the change in y over x2 minus x1. Okay, there's my second formula. Gradient is changing y for changing x, y2 minus y1 over x2 minus x1. Okay, now, example. Oh, hang on. So here's an example now. Find the gradient of that line and hence the equation of the line through these points. Okay, again, I'm not going to give you enough time to do the whole question. Have a think about it. Maybe make a start. 1 minute, maybe 1.5 minutes this time. Bit longer of a question. Okay, have a think, have a look. If you've got a piece of paper, you might have a try. Start it, see where you're going to get to. Is everything working, Mrs. Evans?
Everything seems fine, Mr. Bentley.
Right, because I've got a little thing here that says no internet access. I'll ignore that. Right then, so just going with my recipe idea, and the question is nice, it leads us in there. Gradient. So, gradient. I always tend to write equals m, so I don't forget what we're dealing with. So, y2 minus y1 over x2 minus x1. If I was teaching you this, I'd show you it does not matter one jot which way round you label your x1, y1, x2, y2. The maths sorts itself out. The signs will sort themselves out. So I'm just going to go with the order I've got. Minus 12, 3 is x1, y1, and 5, 7 is x2, y2. If you're reviewing this yourselves after we've finished, you could always flip them around and see if it will still work, just to show you it will still work. Now, signs again. Signs is going to be your problem here. y2, 7 minus 3, all over ruler. I want to be nice and neat. All over x2, 5 minus 12. 7 minus 3 is 4. 5 minus 12 is 17. 4 over 17. Okay. Looks a bit awkward. If I'd got something awkward like that, I would check it. If you've got an answer like that, just check it, make sure it's right. It is right. Okay. So, find the gradient of the line, go back and read the question. This is what your teacher means when they say read the question, because there is more to it, and hence the equation of the line through these points. So, tell the examiner what it is you're trying to work out. Tell the examiner, I'm working out the gradient, that's how I'm going to do it, that's my answer. I'm now working out the equation of the line. So tell the examiner, EQU line. You don't have to write an essay. How am I going to do it? Y minus y1 equals mx minus x1. So m is 4 over 17. Now, interestingly, I'm going to use that as my point, 5, 7. Now, can anybody suggest why? Just write it in chat. Why do you think I would use 5, 7 as my point and not minus 12, 3? Why would I pick that point? What is it about that point that makes it better than the other point? Yeah, I think if you write something there in the question and answer, I think Dr. Evans will be able to see that. I can't see it, so I'm hoping.
Nothing yet, Mr. Bentley.
Pardon?
Nothing yet, Mr. Bentley. There might be typing.
Anybody?
Positive numbers are easier?
Correct. If you're going to make a mistake with this, it's with the signs. So if you've got one of the points with two positives and one with a positive and a negative, ignore the negatives, use the positives. And really, you've called it x1, y1, x2, y2. So in this part of the question, my x1 is 5, my y1 is 7. So I've got y minus 7 equals 4 over 17, x minus 5. I'm petrified of making a mistake here and looking foolish. 17y minus calculator. 17 times 7. I knew it would be a problem. You've all got calculators. 17 times 7 is 119. equals 4x minus 20.
Mr. Bentley, you've gone off the bottom of the screen.
Yeah,
Move the
4x
paper
minus
bit.
20,
Thank
there
you.
we are. And then I would say lots of different ways of doing it. 4x minus 17y is minus 99. So that's one way of doing it. Or any, and where have I gone wrong? Because I've got it wrong there. So, and I think I'm right here. So I think that's wrong. I'll change that to a 99 for you. Right, okay. So, simple, bog standard bookwork question that's very, very popular. Now then, a little bit about parallel and perpendicular lines. A lot of people, you know, when you're teaching primary school pupils, you talk about railway lines and lines that never meet. The best definition of parallel lines is two straight lines are parallel if they have the same gradient. Simple. Now then, if two lines are perpendicular, the product of their gradients is -1. In other words, one gradient is the negative reciprocal of the other. And as Dr. Evans pointed out to me last week, it's the only time she has ever come across a sentence with the word reciprocal in it, apart from the GCSEs where it said find the reciprocal of this. So that's why you did reciprocals in GCSEs, and it'll crop up a lot. There'll be a lot of questions where you're asking to find perpendicular lines and it's the negative reciprocal. So I'm not going to go on to that just yet, but we'll have a look at another point here. My next thing you need to find is the midpoint of a line. What is it? Well, actually, it's the average of the x-coordinate and the average of the y-coordinate. Okay, now I'm a great one for formulas, so I say x1 plus x2 over 2, so it's the 2x value has again divided by 2 plus y1 plus y2 over 2. So you add the x coordinates together divided by 2, add the y coordinates together divided by 2, watch the signs, and you've got the midpoint. Now, a very popular question is this one. Find the equation of the perpendicular bisector of AB. Wait a minute. I've just spotted a mistake here. Find my black pen. It should say of AB, where A is, there we are. Perpendicular bisector of AB, where A is that and B is that. So, again, I'm not going to give you time to the whole question. You might want to just have a minute, just have a think about it, and then I'll quickly fly through this one. One thing you might want to do is on the exam paper is just label. That's where most people who know what they're doing and have revised make silly mistakes. And these little things, labelling your points X1, Y, are trying to avoid us from making the silly mistakes that cost us marks, that hemorrhage marks. And no, a lot of people say, oh, they're only silly mistakes. You know what? More marks are lost when I mark A-level papers on silly mistakes than people who can't do the maths. And it's heartbreaking to know somebody who can do all the maths and loses 20–30%, couple of grades down because they made silly mistakes. So y2 minus y1 over x2 minus x1, which is -1 minus 2 over 4 minus 3, which is -1 minus 2 is -3 over 1. The gradient is -3. So that is the gradient of AB. Next, I mean, a little bit is when you find an answer, underline it. So the examiner I'm conditioned to look at the bottom for the answer. The gradient of AB is -3, tick, full marks, move on. The midpoint of AB, and again, is a formula, which is x2 or x1 plus x2 over 2, y1 plus y2 over 2, which is 7 over 2, because it's 4 plus 3 is 7 over 2, and 2 minus 1 is 1 over 2. So there's the midpoint. Okay, so I've now got the gradient of the line between AB and where the midpoint is. The perpendicular bisector is at right angles to that through that point. So the gradient of the perpendicular is 1/3. Change the sign, find the reciprocal. So here, change sign, reciprocal. And you'll notice here, I've set it up at the bottom. I'm hoping I've got this one right. The gradient is 1/3. My x1 is 7 over 2. My y1 is 1/2. Okay, so again, my same idea, get your bits in place, you're not going to make a mistake. Y minus y1 is y minus 1/2 equals 1/3 x minus 7 over 2. I think I've got my answer wrong again. Never mind. So 3y minus 3 over 2 equals x minus 7 over 2. Okay, and then I get multiplying through by 2, and I get 6y minus 3 equals 2x minus 7, and that would give me 2x minus 6y, and does not equal minus 20 at all. It equals 4. I'm making a right mess of these. Okay, so, and again, simple if you don't make a silly mistake. So let's just recap. Gradient of the line, the midpoint to get the perpendicular bisector goes through the middle, the negative reciprocal, change the sign and reciprocal, put it into the formula for the straight line, and your answer pops out there. Now, the last thing is the length of a line. Okay, and that is using Pythagoras. Again, you may well have done this as Pythagoras on a graph, but the formula is y2 minus y1 all squared plus x2 minus x1 all squared. Okay, which is fine. So here's an example. Find the length of the line segment of the line y equals 5x minus 2 between x equals 3 and x equals 4. Okay, now it's slightly different because I need the y values, don't I? Right, so, and again, it's the same question, find the length of a line, but asking you to think a little bit, because I need x values and y values. If x equals 3, tell the examiner where these numbers are coming from. Y equals 15 minus 2, y equals 13, which gives me 3 13, which I'll call x1, y1. If x equals 4, y equals 20 minus 2, y equals 18, which gives me the point 4, 18. You'll notice all that's happened is they've asked us to do a bit of work before we use the formula. Listen, you're doing A-level maths. There's got to be more to it than simply quote a formula, plug the numbers in, turn the handle, the answer pops out. There's got to be more to it than that. You've got to be thinking a little bit more about what are you given, what can you get from that. And now the length of the line and things like, just get used to the language. The line segment, part of the part of that line is the segment between x equals 3 and x equals 4. Everything's there for us to use if you just don't panic and stay awake. So now the length of the line, so length of the line is the square root. Now I just remember how to do it, but I'll stick with y2 minus y1 all squared plus x2 minus x1 all squared. There are other ways of quoting that formula. So again, if you've got a different way, if you might have x2 minus x1 plus y2 minus y1, you might have the y1 first, and it doesn't make any difference. It's what's in a name. Okay, but that's my way of doing it. I'm afraid it's a calculator problem from there. So y2 is 18 minus 13 squared. What happens here is people make all sorts of ridiculous mistakes with squaring and square rooting and doing all sorts of ridiculous things. Just calm down, and that is plus 4 minus 3 all squared, which is the square root of 5 squared plus 1 squared, which is root 26. And to be honest, at A level, quite happy to leave it as a third. Unless you're going to do anything with it, I wouldn't do anything, leave it as a third, unless you're told to give the answer to a different degree of accuracy. Now then, when you log off, when the session's finished, you will get emailed the resources I've used. So you've got this sheet here. You'll notice there's a couple of corrections to make. My apologies, I'm not perfect. I've never claimed to be perfect. But the other thing I'm going to email you is this. Now, this is from mathmateg.com. If you're not used to mathmateg.com, get used to it. Go on it. It's a bloke at the school there. It is a Welsh medium school, but it's all there in English. Click on the bit at the beginning. It will say Welsh or English. There are English versions of everything, and it does divide you up into C1, C2. That's the old thing. The same people writing the exam, the same sort of questions crop up, and you've got questions now from 2005 all the way up 2005 twice, 2006 twice, 7. There are many questions of the type that you want practice on. If you want to find exam question practice, that's the perfect place for it. The other place is a website called Jack Tilson that you could use as well. Mathmateg is brilliant. It's free. Okay. So what I thought I would do for the end of the session is a question. Now we've got 10 minutes. We're going to be pushed for time, or you will be pushed for time to do it in 10 minutes, because I always say you've got to work at a mark a minute. Okay. So here's the question. I just ripped one of those off it. I don't know which one it was. Let's go back to the camera, and it's here, I hope. So here's the question. The points A and B have coordinates -2 and 10, minus 210 and 12.3 respectively. Respectively means that's point A, that's point B. So 1 minute. Can we find the gradient of AB and the equation of AB? You want to do that now. I was just trying to take a photo of it so I could work through it without you seeing what I was doing. Right, so I'm not going to spend a lot of time talking about that, other than saying it's bookwork. What I call when I say something is bookwork, what I mean is absolutely bog standard. And I think we've done that 3 times now, haven't we? Gradient of a line, then to the equation. That gets you 4 marks to get to there. It doesn't ask us for any particular form of the equation, right? Now, the next bit is reading and not panicking. Now, I know when I used to read things like that when I was 17, it was like, oh my God, it's not English. Well, the line L is perpendicular to AB. So let's look at part B, line L. It's perpendicular to AB, so its gradient is the negative reciprocal of AB. It's right angles to it, so its gradient is 2, right? And it intersects the y-axis at the point 0, -1. Okay, and the lines AB and L intersect at D, right? Write down the equation of L. Now then, you might think, well, that's a bit hard. If the question says write down, it is possible literally to write it down. Well, think about it. Okay. We've got the gradient, and we could use y minus y1 equals mx minus x1, but that is the y-intercept. So the equation of L, y equals mx plus c, y equals 2x minus 1. Write down the equation of L. Show that D, where's D? D is where AB and L intersect. So we've got to solve these 2 equations simultaneously. Okay, now I'm not going to spend a lot of time on simultaneous equations except to say people make heavy weather of them. Watch. AB is x plus 2y equals 18, and L is y equals 2x minus 1. Now, rather than going through all the rigmarole that you were shown at year 11, why not substitute that value for y into that equation there? That's how I would do it. X plus 2 times y, which is 2 times 2x minus 1 equals 18. And I'm looking for an answer of x equals 4. Okay, so x plus 4x minus 2 equals 18. 5x equals 20. X equals 4, and I've moved over to the room before Dr. Evans tells me. So x equals 4 and y equals 7. Well, I can use that. If x equals 4, y equals 2 times 2 minus 1, y equals 7. For a show that question, you have to do enough working to show where the answer is. You've got to do enough working to show where you got the answer from. So it's no good saying x equals 4 and then saying hence y equals 7, not for a question that says show that. Find the length of AD. Okay, now we've got to be careful now, don't we? AD. This is the point D. So D equals 4, 7. Now, the next bit said, no, we're going to out of time, unfortunately. I've only got 3 minutes left, right? And I haven't finished this. So what I will do, I will, if you want to stay on, I will finish it. It'll only take me about 5 minutes max, right? Find the length of AD and the length of BD. Well, we've got a formula for the length of a line. Oh, so I want to show you this before you disappear. Okay. For revision, I use these index cards. You can buy them from WH Smith's. They're not a lot. And I want everything I need to know about coordinate geometry on this piece of card. And you'll notice the equation of a line, the gradient, the bit about parallel and perpendicular lines, the midpoint, the length of a line. If you know all that, you know everything you need to know about coordinate geometry. So everything we've done in this exam question, we can find on this card. Actually making that card yourself is really part of the process. That really does help us to understand what we need to know, and if you're doing any exam questions or past papers, having that in front of you is ideal because you're going to use the formula and learn it. Okay. Now, so
Mr. Bentley, we've had a couple of people indicate that something has gone wrong. How is y equal to 7? Is it 3?
Oh, sorry.
And is x wrong?
No, x is right.
It's probably because the y's gone as
X is 4. Oh, sorry. Hang on. That's better. X is 4. Y is, sorry, is that better, everybody?
Are we all happy with that now?
We're happy with that. It's, listen, I'm suddenly starting to panic and rush because I've suddenly seen I've got 1 minute left and I haven't got time to finish this question. And it is, you know, I'm as fallible as the rest of you. It's just I've got this veneer of being very confident and know what I'm talking about. Trust me, I can make as many mistakes as anybody else. And I'm sure Dr. Evans will tell you the same. Okay? Yeah, you're quite right. Well spotted. That's why when I'm teaching, I do like people shouting out and pointing out my fallibilities. Okay? Now, So it's 6 o'clock now. One thing I would like, just so that I get a feel of, is it being pitched at the right level? Too easy, too hard, too quick, too slow? If you can just let us know in the Q&A before you log off, that will be really useful for me for next week. So I want to make sure that if you're going to invest 40 minutes of your time, then for goodness sake, make it worthwhile. So that is for me to gauge how I'm doing. I will finish off the question now, and I'll try not to rush it too much. Okay. All these will be emailed out to you, maybe not the solutions, but if you review the session, you'll be able to fill them in on your sheet. Okay, so proper revision that. So now then, I'll finish it off hopefully in 5 minutes. So length of AD. I've no issues with anybody who wants to go because they've got to go into another session. That's fine. I won't take offence. Equals the square root of y2 minus y1 all squared plus x2 minus x1 all squared. And we've got, this is AD. So A is minus 210 and D is 47. Incidentally, all these numbers are actually in the question. So if you have made a mess of it somewhere, as long as you use these two numbers in the last bit, you're going to get full marks, which equals 7 minus 10 all squared plus 4 minus 2 all squared. So it's a square root. 7 minus 10 is 3 squared is 9 plus 4 minus 2 is 6 squared is 36. So that is square root 45. Okay. Doing mental arithmetic rather than calculator. Okay. And BD length, I think, is it? Yep. It's again square root of y2 minus y1 all squared plus x2 minus x1 all squared. B is 12.3 and 47 again, which is the square root of 7 minus 3 all squared plus 4 minus 12 all squared, which is the square root of 7 minus 3 is 4 squared is 16 plus 4 minus 12 is 8 squared is 64, which is root 80. Right. So CD is wait a minute, where's C? Right. So CD, wait a minute. One thing I might do now is have a bit of a sketch graph. Now, I'm suddenly lost as to where things are. D is 47. Don't try and make it completely accurate because you've got no chance. A is minus 210. $12.3 is, oh, that's where D's wrong, 47. 12, 3 is B. C is 0, -1. So we've got A, B, C, and D there, yes. Now, CD is extended to E, so D is the midpoint of CE. Aha. So there's the point E up there. So D is the midpoint of CE. Now, this is a very common question. Okay. It looks like it's difficult to get there, but actually, if D is the midpoint of CE, from the X values from C to D, the X value goes up 4, so it should go up another 4 there. So that point there has an X coordinate of 8, and the Y value goes from -1 to 7, which is +8, plus another 8 is 15. So E is at 8, 15. And that is a very, very common technique. And write down the geometrical name for the quadrilateral ABCD. Well, that there and that there, they're the midpoints of both of those. You've got a rhombus because the diagonals are perpendicular and intersect at the midpoints. So that is a bit of geometry to finish it off. Rhombus, right down, nice, easy. And that's the sting in the tail. The sting in the tail is a bit of understanding and a bit of geometry there just to finish us off.